start हो चुका है क्या? So in the last term we studied about aliphatic alcohols. We saw further classification of aliphatic alcohols into monohydric, dihydric, trihydric and polyhydric. Monohydric alcohols were further classified into primary, secondary and tertiary. So we are coming about to the next topic, next type of alcohol, that is allylic alcohols. So in allylic alcohol we have a carbon-carbon double bond. We have a carbon-carbon double bond. And to this carbon-carbon double bond, a sp3 hybridized carbon is attached. This is our sp3 hybridized carbon atom. And if an OH group is introduced to this sp3 hybridized carbon atom, then this type of alcohol is called allylic alcohol. Like this is our sp3 hybridized carbon atom. And if to this sp3 hybridized carbon atom, if a OH group is introduced, like this OH group, so this alcohol is called allylic alcohol. So we have a carbon-carbon double bond, and to this carbon-carbon double bond we have a sp3 hybridized carbon atom, and to this sp3 hybridized carbon atom, if a OH group is introduced, like we have in this example, then this type of alcohol is called allylic alcohol. Fine. Now then comes third type of alcohol, that is vinylic alcohol. That is vinylic alcohol. So there is a slight difference between allylic and vinylic. In case of vinylic alcohol, we have a carbon-carbon double bond, and a OH group is directly attached to this carbon-carbon double bond system. Like this is CH3, this is CH, and this OH group is directly attached to this carbon-carbon double bond, and this type of alcohol is called vinylic alcohol. And this group, this CH3 double bond CH group, is called vinylic group. Okay. So if there is a carbon-carbon double bond system, unsaturated system, and if a OH group is directly attached to this carbon-carbon double bond system, so this type of alcohol is called vinylic alcohol. And this group, CH3 double bond CH, this group is called vinylic group. So we can say that if a OH group is directly attached to vinylic group, then this type of alcohol is called vinylic alcohol. So we saw about second and third type of alcohol, that is allylic alcohol and vinylic alcohol. In case of allylic alcohol, there is a carbon-carbon double bond system. There is a carbon-carbon double bond system, and to this carbon double bond we have a sp3 hybridized carbon atom attached, and if to this sp3 hybridized carbon atom, if a OH group is introduced, alcoholic group is introduced, then this type of alcohol is called allylic alcohol. The third type of alcohol is vinylic alcohol. In vinylic alcohol we have a carbon-carbon double bond system, and to this carbon-carbon double bond the OH group is directly attached. Since this group is called vinylic group or vinyl group, so this type of alcohol is called vinylic alcohol. So these are the next two types of alcohol, that is allylic and vinylic. Now let us move forward to the fourth type of alcohol, that is benzylic alcohol. Fourth type of alcohol, that is benzylic alcohol. Benzylic alcohol. In case of benzylic alcohol, we have a aromatic system, and a OH group is introduced to the side chain which is directly attached to this aromatic system or benzene ring. Like we have this OH group, and this OH group is attached in the side chain. This is our side chain, and this is our aromatic system or phenyl group. So according to IUPAC nomenclature, this is our first carbon atom, this is second carbon atom. So its IUPAC name would be 2-phenyl ethanol, because it is attached to the side chain. According to our IUPAC nomenclature, this phenyl group acts as a substituent group. So its name would be 2-phenyl, and this is alcoholic group ethanol. We take one more example. This is our benzene ring. This is is our benzene ring. And to the side chain, again one OH group is introduced, that is alcoholic group is introduced. This is our OH group. Again, because the OH group is introduced in the side chain, which is attached to our benzene ring, that is phenyl ring. So again, it is an example of benzylic alcohol, and its name would be 3-phenyl propanol. Okay. So these are the examples of benzylic alcohol in which OH group is introduced in the side chain, which is attached to the benzene ring or aromatic system. So we saw two examples of benzylic alcohol, that is 2-phenyl ethanol and 3-phenyl propanol. So these both are the examples of benzylic alcohol. So these was all about of classification of alcohols. So we saw four types of alcohols: aliphatic alcohols, allylic alcohols, vinylic alcohols, and benzylic alcohols. In case of aliphatic alcohols, we saw further classification, that is monohydric, dihydric, trihydric, and polyhydric. In case of monohydric, we saw primary, secondary, and tertiary alcohols. So this was all about classification of alcohols. So in case of aliphatic, we saw carbon chain, straight carbon chain, and a OH group was introduced in that straight carbon chain. In case of allylic group, we saw allylic alcohol. We saw that we have a carbon-carbon double bond system, and to that carbon-carbon double bond, a sp3 carbon was introduced, and if to that sp3 hybridized carbon atom one OH group was introduced, then that example was of allylic alcohols. In case of vinylic alcohol, we saw that there was a carbon-carbon double bond system, and a OH group was directly introduced to that carbon-carbon double bond system. Since that CH3 double bond CH group is called vinyl group or vinylic group, then because of that, the whole alcohol molecule was called vinylic alcohol. And in this type of alcohol, benzylic alcohol, we saw that we have a benzene ring, and we have a straight chain, a side chain which is attached to this benzene ring, and to this side chain we have a OH group introduced in both the cases. Since the OH group is not directly linked to our aromatic system, it is present in the side chain which is directly attached to this aromatic system. So it is an example of benzylic. Fine. So let us move forward to other cases. Now we are moving towards classification of phenols. Classification of phenols. So the classification of phenols are not so much complex as we saw in case of alcohols. Phenols are classified only on basis of how much OH atom is directly attached to their aromatic system. So they are only of three types, that is monohydric phenol containing only one OH group directly attached to the benzene ring, that is dihydric, second one is dihydric phenol, and the third one is trihydric phenol. And in case of phenol, the OH group is directly attached to the benzene ring. There is a direct attachment of OH group with the benzene ring. Okay. So in all the three cases, monohydric, dihydric and trihydric phenols, we will see that the OH group will be directly attached to the benzene ring. Okay. So that is the most important difference between benzylic alcohol and phenol. In case of phenol, the OH group is directly attached to the benzene ring or aromatic system. But in case of benzylic alcohol, the OH group is attached in the side chain, which is attached to the benzene ring or aromatic system. So we are moving forward for the first type of phenols, that is monohydric phenols. So we know that monohydric means only one OH group. So you will see that only one OH group will be attached to the benzene ring. It will be attached to the only one OH group will be attached to the benzene ring. Like for example, the most common example is itself phenol. Since only one OH group means monohydric phenol, and OH group is directly attached to the benzene ring, so it is an example of monohydric phenol. The other one we can say CH3 OH orthocresol containing only one OH group which is attached to the benzene ring, and we have a CH3 group. OH group, CH3 group, metacresol again containing only one OH group, and paracresol containing again only one OH group. So because OH and CH3 group are at para positions, so it is paracresol. Here they are in meta positions, first and third position metacresol, and here they are at first and second position, that is orthocresol. So in all the cases we are seeing that only one OH group is there which is directly attached to the aromatic system. Because OH group is directly attached to the aromatic system, so it is a case of phenol, and only one OH group is attached, so these are the examples of monohydric phenols. So in case of monohydric phenols, we have example of phenol, orthocresol, metacresol, and paracresol. These are the examples of monohydric phenols. Now we are moving forward towards dihydric phenols. Dihydric phenols. So we know in case of dihydric phenols, two OH groups will be there attached to the benzene ring. To the aromatic system, two OH groups will be required. Dihydric phenols, two OH groups directly attached to the benzene ring. Like we have example OH group at first and second position. This is commonly called catechol, or its IUPAC nomenclature would be 1,2-dihydroxy benzene. Second would be if the OH groups are attached at first and third positions, that is resorcinol, commonly called resorcinol. When they are at first and third positions, when they are first and second position, this is called catechol commonly, and when the OH groups are first and third position, it is called commonly resorcinol, or its IUPAC name would be 1,3-dihydroxy benzene. And the third case, when the OH groups are attached at first and fourth positions, this is first position, this is fourth position, then it is commonly called quinol, or it is also called hydroxyquinone. And its IUPAC nomenclature would be 1,4-dihydroxy benzene. So this was all about monohydric phenol and dihydric phenol. In case of monohydric phenol, there is only one OH group which is directly attached to the benzene ring. Like we have example of phenol, orthocresol, metacresol, and paracresol. In case of dihydric phenol, we have two OH groups which are directly attached to the benzene ring. Like if the attachment is at first and second position, commonly called catechol, and the IUPAC nomenclature is 1,2-dihydroxybenzene. When the attachment is at first and third carbon atom, it is commonly called resorcinol, and the IUPAC name is 1,3-dihydroxybenzene. And when the attachment is at first and fourth carbon atom, it is commonly called quinol or hydroxyquinone, and the IUPAC name is 1,4-dihydroxybenzene. So this was all about monohydric phenol and dihydric phenol. Next, we are going to discuss about trihydric phenol. Trihydric phenol. So we know in case of trihydric phenol that 3 OH groups will be present attached to the benzene ring. It will be attached to the benzene ring. Okay. So, like we have some examples of trihydric phenols. First case would be when the attachment is at first, second and third carbon atoms. This is commonly called pyrogalol, or its IUPAC name would be 1,2,3 trihydroxy benzene. This would be its IUPAC name. Second example is when the 3 OH groups are present at first, second and fourth positions. That is first, second and fourth position. This is commonly called hydroxyquinol. Like we saw in case of quinol, this was quinol, and then to this structure of quinol, one more OH is introduced at second position here. In this case, so it becomes hydroxyquinol, or its IUPAC name would be 1,2,4 trihydroxy benzene. Or third example would be when the attachment of OH groups are at first, third and fifth carbon atoms, that is first, third and fifth carbon atoms. So it is called 1,3,5 trihydroxybenzene. That is its IUPAC nomenclature, or its common name is fluoroglucinol. That is common name, fluoroglucinol. So this was all about classification of phenols. In classification of phenols, we saw about 3 classes of phenols: monohydric, dihydric and trihydric. In monohydric, there is only one OH group that is directly attached to the benzene ring.